Hi and welcome back to A+ Maths. This is Heidi Postle. Today what I'd like to do is a revision of the coordinate geometry topic in Year 9, 10 and 11 2-unit advanced maths. It actually doesn't matter what year you do this topic. All the rules are exactly the same except for two, which I don't think will affect you if I teach them at the same time. I'll make it very clear which of the two rules for the Year 9 and 10s. However, a lot of teachers do tend to teach these in Year 9 and 10 as preparation for Year 11 and 12. There are 14 rules in this topic to know. Of those 14 rules, you should already know 6 of them from Year 7 and 8. That means that there's really only 8 things that are new to this topic, and they're actually not that hard to understand. So let's get into it, and you should have no problems with this topic. I'd like to start with the distance between 2 points. Here is our first rule. It's the distance formula, and it tells us the distance between 2 points. The formula itself looks complicated, but in actual fact, it's just Pythagoras' theorem, which is what you learnt in Year 8. So let's have a look at how to use it using Pythagoras, and then we'll show everybody how to use it using the actual formula, and you can make a decision on which one's best for you. So I've already drawn some examples on the board. Example number 1, we need to find the distance between the points A and B. Now you all know how to find the distance between 2 points. You can say, I have a vertical line down here, and I have a horizontal line across there. By doing that, by drawing a horizontal and vertical line, I create a right angle. Once I have a right angle triangle, I can then use Pythagoras to find the length of the hypotenuse. The coordinates of point A are 1, 10. If it helps you to write them on the side, then you should do that. The coordinates of point B are 5 and then 2. So I can find the length of my right angle triangle quite easily. What's the length of that distance there? It'll be from 10 to 2. So that distance there is 8. If you haven't labelled them on the X and Y axis, it's a little bit more tricky to figure out what they actually are. If you're trying to find the distance here, it's from 1 to 5, so that distance is 4. 5 take away 1 is 4. Once I know that length and that length, I then can use Pythagoras, c squared equals a squared plus b squared. Remembering that the hypotenuse is always the longest side, which is x, which is 4 squared plus 8 squared. You can use your calculator to work out what 4 squared plus 8 squared is. You would type in 4 squared plus 8 squared equals, you get 80. And then to get rid of the square root, you would square root both sides. And you get the square root of your answer, or 80 if you can write it in, is 8.9. And that's to 1 decimal place. Let's have a look at number 2. I'm going to start off by doing all of these using Pythagoras, and then I'm going to go back and do the same questions using the rule and show you that it's the same thing. Over here we have A and B. I can label my points 2, 7 and -2, -5, and I want to draw a horizontal and a vertical line. There's my right angle, as expected. I need to find the length of AB, which is my hypotenuse, because it's opposite the right angle. Then I have to find the length of the other two sides. This one's going from 7 to -5. Be very careful. That distance there is 7. That distance is 5. So even though that's a -5, I actually need to go 7 plus 5, which is 12. Over here, what's the length of this line? From -2 to 2. So that distance there is 4, because from there to there is 2, and from here to here is 2. Now I can use Pythagoras. C squared equals a squared plus b squared, We all should know how to use Pythagoras by now. X squared equals 4 squared plus 12 squared. And remember, it doesn't matter which order I put the 4 and the 12. Doesn't matter 4 squared plus 12 squared or 12 squared plus 4 squared. If you can't do it in your head, use your calculator. You have 160, and then you find the square root of both sides. And at the moment, I'll just do them to 1 decimal place. So that's 12.6 to 1 decimal place. Everybody following so far? Really, I haven't shown you anything new yet. This is all Year 8 work. It's just finding the distance of 2 points on a coordinate axis. Again, we're going to draw a horizontal and vertical line coming from my points. There's my right angle. And then I like to label the actual coordinates with the points so that I can figure out the distances more easily. That's 3, -1, 6, 3, -2. Now I'm going to figure out all the lengths of all the sides. I might use a different colour just so that it makes it easier. So from 6 to -2, that distance is 8. From -1 to 3, that distance is 1, that distance is 3, that distance is 4, and that's x. So I have Pythagoras. X squared equals 4 squared plus 8 squared. So x squared is going to equal 80, and then x equals the square root of 80, 8.9 to 1 decimal place. So we should have no problems there. Everybody get that? Remember, it's just Pythagoras. Now what I'd like to look at are the same examples. Take a look at the examples I've written on the board now. A and B, all the coordinates of these 6 points are exactly the same as the coordinates of the 3 questions that I just completed using Pythagoras' theorem. Except this time, I don't want to use Pythagoras' theorem. I'm going to use the formula. And I want you to understand, and I want you to realize that using the formula will give you exactly the same answer as using Pythagoras. And you can choose which method's best for you depending on the question. Let's have a look at example number 1. So I have my rule, and I'm trying to find the distance AB. That's the question for all of these. Find the distance between A and B. As soon as I know that I need to find the distance between 2 points, I write down my formula. The distance formula says y2 minus y1 squared plus x2 minus x1 squared. Now I've deliberately written it the wrong way, the other way around, because depending on your teacher's preference or your textbook, they can write it either way. So don't be afraid if they've got the y's first or the x's first. It makes no difference. We can pick and choose whatever we prefer. Once I've got my formula written down, I actually need to label the points. And in my opinion, the most important part of this formula, or any of these formulas, is labeling the points first. I'm going to call this point x1, y1, and I'm going to call this point x2, y2. It is very important that the 1's go together and the 2's go together. You can't call this point x1, y2. This point is x1, y1, and this point is x2, y2. If you wrote them the other way around, and you made that one x2, y2, and this one x1, y1, that's okay. As long as the 1's are the same and the 2's are the same, with the same point, you'll be fine. All you need to do now is be very careful, substitute the right numbers in the right spot, and we're done. So we have y2 minus y1 squared plus x2 minus x1 squared. Now if you like, you can just get your calculator, put everything in on the calculators. Don't put the square root. Notice I've still written the square root down. Just do bracket 2 minus 10 bracket squared plus bracket 5 minus 1 squared. Type it in exactly how it appears and you should get 80. So D is the square root of 80. If they want your answer to be exact, you would leave it like that. Or if you know surds already, then you would be able to simplify it. If they want the answer to 1 decimal place, then you would write your answer as 8.9 to 1 decimal place. And if you all go back to the last example that I did, just rewind really quickly, you should see that we got 8.9 for example number 1. Except this time we used the formula. And last time we used Pythagoras. But remember, they're the same thing. Let's have a look at number 2. We're going to find the distance between these 2 points. So I'll write down the rule. This time I'll do it the same as what I wrote up there. Just to show you that it makes no difference. I'm going to label my points x1, y1, x2, y2. And then I'm going to sub them in where they belong. x2 is minus 2. Minus x1 plus y2 minus y1 all squared. And then I should just be able to put it in exactly how it appears. Minus 2 squared plus minus 5 minus 7 squared equals 160. And so the distance between A and B is the square root of 160, which is 12.6 to 1 decimal place. If you rewind it and have a look at when we did the same example using Pythagoras, you'll see that we also got 12.6 for the distance between A and B. Lucky last, why don't you have a go at this before me? Pause the video, have a go at it on a piece of paper, and then check it. We write down the formula, always write down the formula, remembering it doesn't make any difference which order. x1, y1, x2, y2. So we need to substitute into the formula. Be careful that you put the right numbers in the right spot. y2 minus y1 squared plus x2 is 3 minus x1, be careful, minus 1 squared. Write it down twice. Then we get our calculator. We just substitute it in exactly how it appears. Don't put the square root on the calculator. If you do too many things in the one time, you'll just get it wrong. 3 minus minus 1 squared. We should get 80, like we did before, and then actually find the square root of it. The square root of 80, we've already done it on the other side, to 1 decimal place. And that's the distance between 2 points. Anytime you're asked for the distance between 2 points, you can either draw the picture and use Pythagoras, or you can use the formula. Some of you will have already noticed that you obviously can't use Pythagoras if you have the numbers written next to each other like this. You'll always have to draw the picture, label the points, and then draw the right angle triangle. So it's not always more convenient to use Pythagoras. You actually need to know how to do both, the formula and using Pythagoras, but just know that they're exactly the same. Thanks for watching. See you soon. Don't forget to share, like, and subscribe.